Hello everyone, I am Dr. Anjali Bodade from Department of Chemistry, Shri Shivaji Science College, Amravati. Well, today we'll be discussing about the general aspects of bromine and handling of liquid bromine. Students, mostly it is considered that bromine is a scary liquid. If you're pouring a bromine on your hand, it will never say excuse. It will penetrate and it will come down from the lower side. So generally it is referred as a scary liquid, but we find that really it's a fascinating liquid. The unique liquid element, bromine, is a brownish red liquid. It has a colored vapor with an offensive and suffocating odor. It is the only non-metallic element that is liquid under ordinary conditions. It evaporates easily at STP in a red vapor that has a strong, disagreeable odor resembling that of chlorine. Bromine was discovered by Antony Ballard in the year 1826. Atomic number of bromine is 35. Its atomic mass is 79.904 gram per mole inverse. You can see the electronegativity value, the melting point and the boiling point. So these are the few chemical properties which I have considered. Regarding the position of a bromine in the periodic table, it belongs to 4th period and the 7th A group of the periodic table. Let us see a fascinating reaction of liquid bromine and aluminium. As you can see, the bromines are stored in ampoules. When bromine is poured into the test tube, you can see the reddish brown dense fumes. Now to this test tube, when a rod of aluminium is being added, you see the vigorous reaction which is occurring. Yes, you see the intense fumes which are being liberated, the high reactivity of liquid bromine, and at the end we find a precipitated, whatever is formed is an aluminium bromide. I hope you all enjoyed the reaction. Applications. Bromine is used in industry to make organobromo compounds. A major one was dibromomethane, an agent for leaded gasoline. Organobromines are used as insecticides, in fire extinguishers, and to make pharmaceuticals. It is used in making fumigants, dyes, flame-proofing agents for water purification compounds, sanitizers, medicinals, agents for photography, and in bromates, vegetable oil. Used as an emulsifier in many citrus-flavored soft drinks. Let us have a glance at the bromine in the environment. Bromine is a naturally occurring element that can be found in many inorganic substances. Bromine salts have accumulated in seawater from which bromine is extracted. Humans, however, have for many years ago started the introduction of organic bromines in the environment. These are all compounds that are not natural and can cause serious harm to human health and the environment. Health hazards of bromine. Breathing bromine gas could cause you to cough, have trouble breathing, get a headache, have irritation of your mucous membrane inside your mouth, nose, dizziness, have watery eyes. Getting liquid bromine or gas on your skin could cause skin irritation and burns. Liquid bromine that touches your skin may first cause a cooling sensation that is closely followed by a burning feeling. Environmental effects of bromine. Organic bromines are often applied as disinfecting and protecting agents due to their damaging effects on microorganisms. When they are applied in greenhouses and on farmlands, they can easily rinse off to the surface water, which has very negative health effects on Daphnia, fishes, lobsters, and algae. Organic bromines are also damaging to mammals, especially when they accumulate in the bodies of their prey. The most important effect on animals are nerve damage and next to that DNA damage, which can also enhance the chances of developing cancer. Organic bromines are not very biodegradable. When they are decomposed, inorganic bromines will consist. These can damage the nervous system when high doses are absorbed. So if these are the health hazards, let us take a glance at the special handling and storage requirements. Precautions for safe handling. Never work alone with extremely hazardous material. Avoid contact with skin and eyes. Avoid formation of vapors, dust, mists, and aerosols. Use appropriate exhaust ventilation. Use appropriate personal protective equipment. Keep flammable, pyrophoric, potentially explosive, and water reactive chemicals away from sources of ignition. Even in a lab, when we are performing bromination of acetanilide, we carry out the experiment in the corridors where there is good ventilation and the reaction can be easily performed. Conditions for safe storage. Keep containers tightly closed and in a cool, dry, and well ventilated location. Keep a proper storage cabinet and shelving. Use lowest shelf possible. Assure chemicals are properly labeled. Segregate incompatible chemicals. Decontamination procedures. Wearing proper PPE kit. Laboratory work surfaces should be cleaned at the end of each workday. All materials, disposable gloves, wipers, bench paper that are contaminated with chemicals should be disposed of as hazardous waste. Proper and complete hazardous waste labeling of containers is important. The contaminated waste should be placed in a metal container away from the combustibles to prevent fires. Verify the material is no longer pyrophoric before placing waste in with other combustible waste. About the waste disposal procedures, label waste, Hazardous waste labels must be placed on the hazardous waste container up to the start of the accumulation. Store waste. Hazardous waste containers must be kept closed except when adding waste. Hazardous waste containers must be stored in a secondary containment to adequately contain all of the contents of the container. Hazardous waste containers must be inspected weekly for signs of leaks, corrosion, or deterioration. Dispose of waste. Hazardous waste must be transferred for disposal within 6 months of being generated. Empty containers. At no time should full or partially full containers be placed in the trash. Do not dispose of chemicals by pouring them down the drain or placing them in the trash. About the spills, if you cannot assess the condition of the environment well enough to be sure of your own safety, do not enter the area. If possible, help contaminated or injured person. Evacuate the spill area. Avoid breathing vapors from spill. If possible, confine the spill to a small area using a spill kit or absorbent material. Keep others from entering the contaminated area. Use caution tape, barriers, etc. Minor spills. In the event of minor spills, if there is no potential hazardous chemical exposure, report the spill and proceed to clean it. If you are trained, use appropriate personal protective equipment and cleanup material for chemicals spilled. Thank you, students.